Right, since the last video I've soldered the plus 12 volt wire back under here. I've also put the fan ducting back on top of here and here, just to make sure everything stays nice and cool. Also sorted out this rear panel harness as well. You'll probably remember all this garbage here that from the first video that was hanging from the wiring back here. So that's all gone now. Basically I've just put it back as it was in the manual. There was also a link in here that was actually missing. They'd actually shorted clear to send on the CRT port just to ground, but in the manual there's actually a link between CTS and RTS. So basically everything you see now, hopefully, is as it left the factory. We've got a few little checks to make on this board and links. So what I'll do, I'll just reposition everything. We'll have a look at that board, then we can do a bit of testing. Right, this is the monitor board. There's a few links on here we need to check. You can probably see these links here, the little row of links here. These set the baud rate of the serial port on the CRT and the teletype. At the moment I've got 23 and 24 linked. That will give us 4800 baud. You might remember from the original video there was a link between 21 and 22, which was a little white wire which actually fell off. So I took the opportunity to increase the baud rate to 4800. There's some further links over here. Let me have a look. There's one there and there's one there. Now they select the CRT port to be RS232 rather than 20 milliamp current loop, so that's the main settings you need to worry about on this board. This switch here needs to be backwards to enable the Monitor Rom over here. Okay. You might also remember from the first video there was a load of wires at the top here. I've removed all of those. You might just be able to see there's a little bit of solder left on these pins here, but they're a bit as clean as I could get them. There's still a break on the back. See if I can find it. Oh, just there. I haven't fixed that yet, but that'll have to be fixed. They've actually cut through the track, so they could put the 5 volt on there, so that needs fixing at some point. And it won't affect us for this video anyway. The final set of links are actually over here in the corner, but it's unlikely you'd need to alter these. These actually set the base address of the Monitor Rom, but they're actually PCB traces, so if these traces haven't been cut then you should be absolutely fine. Right, that's it for the settings. What I'll do, I'll get all this all back together again and then we'll power it up. Right, we're all ready to go. The theory is here. We power up the system. We then depress the boot button, which overlays the bootloader on the bottom of memory. Then we hit the reset button to reset the processor. And then at that point the system starts to scan the CRT and teletype ports. And to assign the console we press space on the terminal and that will assign that to the console, and hopefully it should come up with a boot prompt. Right, so let's give that a go. Right, we're on. Power lights on, halt and run are both off at the moment. Right, so we'll depress the boot button and press reset. Right, the run lights come on, this is a good sign. And if we press space on the terminal, absolutely nothing happens. Well, I didn't expect that, did you? Right, looks like I'm going to have to do a bit of troubleshooting now. Alright, let me reset up and we'll have a little probe round. Right, we're all set up for a bit of probing. Probably just for completeness I should point out that the serial cable I'm using is just straight through. All you need is 2, 3 and 7 ground, transmit and receive. As I said earlier, the request to send and clear to send is actually looped back in the big blue connector at the top here, so that's not a problem. Right, so what we've got, this is the USART for the CRT port and this is the USART for the teletype. or serial chips, whatever you want to call them. They sound a bit more posh calling them USARTs, don't they? Right, so let's have a little prod round. We know that these two serial chips should be being scanned by the bootstrap. So the first thing we'll do is we'll have a little look at the chip selects and see if that's actually happening. Right, let's power up. I'll reset the machine. Now pin 4 is where the chip select is, so we should see, right, and we do, hopefully you can see that on the camera, the Logic Pro is flashing away quite happily there. And on this one here, again, so both the USARTs are being scanned. Another thing we can see is that this bottom pin is the receiver buffer ready. That will flash every time that a character is received. So if I just type some sort of random value, oh hang on a sec, it's fallen off. I'll type some random values on the keyboard and you can see the Logic Pro flashing away. Now what it's looking for is the space character. So if I press space, we see you get one flash, but if I then press in anything again, it's just not doing anything. So at that point it seems to be a little bit dead. Also, it's still chip selected, interestingly, but nothing's happening here. I'm having trouble getting this probe to stay on. Right, here we go. Let me just try it again. Yeah, see, that's completely dead now. If I reset the machine again, presumably, yeah, we can see characters arriving. So something's obviously going wrong there. Another thing we can try is that the chip select on the Monitor Rom is over here. So this should be high at the moment. It will go low when it's active. Again, I'll just type some random characters on the keyboard. It's high. So when I press the space bar, we should see a low on that as it transfers control to the Monitor Rom, which we do. It's flashing away and it's stopped. Now that looks to me like what's happening is it's the scanning of the console is working okay. It's transferring control to the Monitor Rom and then it's crashing. Right, so we're going to have to do a bit more investigating now. What I'll do now is I'll shut it off again and connect it up to the logic analyzer and we'll try and figure out what's going on. Right, we're all ready to set up. Apologies for the noise, that's the fans on the analyzer. We've got the data and address lines connected to the processor on an extender card. Also clocked it on the back edge of data bus in, so we'll only see ins to the processors, we won't see anything out. But that's not a problem because all we want to do is sort of follow the code at this stage. Right, let me just pan round to the analyzer. Hopefully you can see. There we go. I've also put my own Monitor Rom in. Reason being is that I know what's in that and I don't know what's in the Intel one, so otherwise it's going to be tracing, it's going to be really difficult. We could trigger on 0, of course, where the processor vectors to. Problem with that is we're going to get loads of data that we're not really bothered about. We already know the bootstrap's running, so what I've chosen to do is to trigger at the point we hit the spacebar on the laptop. And we know from the reference manual that the status port on the CRT USART is at F7. The F7 is repeated on the upper address bus on the 8080. That's why I've put in F7, F7. And the data available flag is on bit 1, so I put a 1 in there. So as soon as we press the space bar on the laptop, it should trigger. At least that's the theory anyway. Right, so let's go back to list mode. And we'll turn the MDS on. Reset. We'll arm the analyzer. So it's looking for the trigger now. If I press the space on the laptop, we should see a trigger. Right, so it's seen it and it's filled up. Right, so let's see what we've got. I'll turn the MDS off because it's collected all the data now anyway, and it's quite noisy. Right, so here's the trigger point. F7, that's the status port on the USART. That's a 7, so the data available bit was definitely up at that point. So if we start to scroll through, it's going through the monitor ROM here. At this point, F6, that's the data port on the USART, and it's read back 20, which is ASCII for space, which is what we've just pressed on the laptop. So that bit's correct. If we carry on scrolling down through, at point 22 it reads port 78. That's the floppy disk controller. What it's doing, it's checking to see if the floppy disk controller is ready to go. And obviously we haven't even got boards in at the moment, so that test is obviously going to fail. Right, let's scroll down a bit further, and we should get to the boot vector, or sorry, the jump vector I should say. Right, now this is the jump vector, FD3C, where I've put a jump into my monitor code. So I've said jump, which is C3 to F800. So the next we dial down here, we see we've arrived at F800, and hopefully if I bring the listing over, hold on a sec. Right, this is my code. So if we look at just here, we've got 310030, and if we look on the analyzer, we've got 313030, which is correct. So it gets through that bit all right. It then does a call, that's what this CD is, to FB9B. Now it gets to FB9B and it reads CD A9FB. Now if I go through here, right, here we go. Right, at FB9B, which is here, we should be seeing E1 7ECD, and we're not. We're seeing CD A9FB. So it's picking up the wrong data, or it's going to the wrong address. One of the two. Now I've had a really good look through, and what I think's happening is it's actually going to address FB1B. If I find that in the listing, let me just find that part in the listing. Okay, so this is address FB1B, and you'll see we've got CD A9FB, which is, if you look here on the analyzer, we've got CD9FB. Now this looks like it's going to be an address line problem, because if we look at my little sketch here, this is where we were going to go, and this is where we ended up. Now I've broken this up into binary, both sets, and as you see, these sets are fine, these sets are fine, but these aren't. So it looks like A7 is permanently 0, and that's why we've ended up with this problem, because every time A7 should be a 1, it's not, it's a 0, and it's directing the process to completely the wrong location. I've sort of fiddled around, and it looks like the problem's actually even worse than that, because if you sort of move the card around or sort of push on it, various things seem to happen. So it looks horribly as though that either the socket or there's a problem on the board. Hopefully it's just the socket on the ROM. What I can do though is I'll jump her across A7 from the processor card, and we'll see if that actually runs anyway. So let me just set that up. Right, I've jumped across A7 from the processor card. We're looking at the stale data on the analyzer at the moment. This is from the previous run. Right, let me restart the MDS. Reset it. Right, well, on the analyzer, and I'll press spacebar. Keep an eye on these figures here. I'll press space on the laptop, and there we go. We're now getting the correct values. If we look at the listing, you can see the E1. A bit further down, you can see the CD, there it is, 3E, FB, which is there. Right, so it has actually booted. I don't know if I'm going to swing the camera around far enough so you can see it, because unfortunately the laptop's quite a long way down. I'll try and pick the laptop up for you. There we go. So you might just be able to see, it's a bit wobbly because I'm holding on my but the monitor has actually booted. See it coming up. I can actually display a bit of memory probably. There we go. So there you go. So it is actually working now. What I have to do now is investigate what's going on with the card and find out what's happened, because definitely A7's missing. The problem with it is I've been fiddling around with this for a few hours trying to get the a good result to show you, and it's very flaky. So it looks to me like it might be the socket. So anyway, we'll get that on the bench next and we'll see what happens. Right, we're back on the bench with the monitor card. I probably should point out that I did check that the A7 line on the ROM was open circuit before I jumped it from the CPU card. Clearly, if I'd jumped it into a dead short, that would have been a really bad idea. So anyway, I think it's probably the socket. These two ROMs have got common address lines, only a data bus that's separate. So if I can get a decent connection on this one, just get hold of that. If I press on here, it's open circuit, but if I push a little bit harder, just get hold of it, you notice I can get a short circuit between the two, and as soon as I take the pressure off, it goes open circuit again. Well, it does sometimes. This is why it's so flaky, but you can see how flaky it is. So I'm pretty sure it's the socket, so I'm going to swap that out now and then we'll come back and give it another go. Right, so I've changed the socket. Wasn't that easy. Unfortunately, a lot of the tracks were actually underneath the socket, so in the end I ended up popping the top of the socket off, desoldering it from the socket side of the board. It seemed to work out a lot better. Anyway, I've got the original Intel ROM in, the monitor board's back in the system, and we're going to give it another go. So here we go. Now on, boot switch in, hit reset, run lights come on, spacebar on terminal, hurrah! Something's come up. We need to release the boot switch to get the thing to come up completely. Right, there we go. So finally it's working. This video is getting a bit long now, so what I'll do, we'll have a little run through the monitor in the next one. So I shall see you next time.